So before we start our FRQ, I want to review one thing, and that is the chain rule. So the chain rule is if you have a composite function, meaning you have a function within a function, its derivative is going to be, we say the derivative of the outside, which is the f. Keep the g, the inside, the same. Then you multiply that by the derivative of the inside. So you're going to see this listed in several ways. The first type of thing that you might see is something like cosine of ln of x. So the derivative of that, I'm going to write it as d of dx. So d dx of cosine ln of x. So to find the derivative of that, I'm going to do the derivative of the outer part of that, which is my cosine. Derivative of cosine is negative sine. When I do that, I am going to keep the ln of x the same. But then I have to multiply that by the derivative of the inside, which is ln x. So that gives me 1 over x. So my answer for this would be negative sine ln x all over x. The other type of problem that you're going to see for something like this is something like this type of problem. So they tell me g of x equals f sine of x, find g prime of x. So for this type of problem, you're not actually going to be able to find the full answer. You're going to have an f in the end. So for this one, g prime of x is going to be evaluated using the chain rule. So I do the derivative of the outside, which is my f prime I mean, keep the inside the same. I multiply that by the derivative of the inside, which is cosine of x. Be careful, I can't multiply the cosine and sine, but this would be my final answer for that. Usually you have to plug in a value for the x. You're gonna see one of those in just a minute. This is a really common AP question. There's a very good chance you'll get something like this. I have a table. I know that g of x is a composite function. I need to find the value of g prime of 3. Before I can find g prime of 3, I need to find g prime of x. I need to evaluate that. So now I'm going to use my chain rule. I do the derivative of the outside, which is f prime, keep the inside the same. Now I multiply that by the derivative of the inside, which is the x squared minus x. So I end up getting that g prime equals f prime of x squared minus x times 2x minus 1. If you get this part correctly, that's worth the first point of the problem. Okay, so then the second thing I need to do for this problem is I need to evaluate this with g prime of 3. When I do that, I get f prime of 3 squared minus 3 multiplied by 2 times 3 minus 1. That gives me f prime of 6 times 5. If you look up at the table, f prime of 6 is 4, so my answer ends up being 20. This is a 2-point problem. This is going to be the second point if you do that. So the second part of the problem is pretty challenging. It looks like it's unsolvable because they don't actually give you a function for f. Like if you were to try to find f double prime, you would not be able to do it based on what they give you. But what you can do is you can actually evaluate g double prime of x. So we found out in part A that g prime of x was f prime of x squared minus x times 2x minus 1. We can use that to find g double prime. That's going to be the derivative of g prime. So the way that we're going to do this, there's a lot going on. If you look at this derivative, I have a product. This is my first thing, and then this is my second thing. So if you remember the product rule, it is the first function times the derivative of the second plus the second times the derivative of the first. That'll give us the derivative. So I'm going to use that up here. My first function is f prime of x squared minus x. Derivative of the second is going to be 2. That's the derivative of 2x minus 1. I then do that plus the second, which is 2x minus 1, multiplied by the derivative of the first. Okay, derivative of the first is pretty tough. You're going to use the chain rule again. So you start by doing the derivative of the f prime. Derivative of f prime is f double prime. Keep the inside the same. Then you multiply that by the derivative of the inside, which again is 2x minus 1. This part of the problem is actually 2 points. So more likely than not, people who get 2 points, people who will get either 2 points or 0 points, but you get 2 points for doing two things. You need to show that you're using the product rule, and you need to show that you're using the chain rule for that very last part. You're welcome to simplify, but there's not really much that you can do. It's not necessary to simplify this to get full points, actually. So now I need to figure out what f double prime of 0 is. So the only thing I can really do with this equation that I have is I could set x equal to 0. Then I might actually get something that I can work with because I know g double prime is 0 and I know I'm looking for f double prime. So I'm going to rewrite this with a 0 replaced with an x replaced with 0. So g double prime of 0 is equal to f prime x squared minus x. Actually, I'm going to plug in 0 for both of those. So 0 squared minus 0 times 2 plus 2 times 0 minus 1 multiplied by f double prime of 0 squared minus 0 times 2 times 0 minus 1. So next step, I'm going to simplify everything out. You're welcome to replace the g double prime of 0 right now if you want to. You don't have to. So I get f prime of 0 multiplied by 2 plus I'm actually going to end up with a negative 1 and another negative 1. So I get negative 1 times negative 1, which just gives me a 1, times f double prime of 0. It's a good sign that I got an f double prime of 0 because that's what I'm trying to find right now. Now I can plug in values for the things that I actually know. So I know that g double prime of 0 is equal to negative 1. I know from the table up top that f prime of 0 is equal to 2. So I actually now have an equation where I only have one variable, and that's the f double prime of 0. I can solve that out, and I end up getting that f double prime of 0 is equal to negative 5. So actually this last part seemed really long, but that's only worth 1 point. So this full part of the question is going to be worth 3 points. So for part C, they ask, is there a value C for 0 is less than C is less than 3 such that g of C is equal to 5? So if you see a problem where they're asking you, is there a value C? That is almost a sure sign that they are looking for either the mean value theorem or the intermediate value theorem. Occasionally it's Rolle's theorem, but almost always either mean value theorem or intermediate value theorem. So if you see that type of thing, just know it's probably one of those. So whenever you're using either the mean value theorem or the intermediate value theorem, that the first thing that you need to do is make sure that the function is continuous. So we don't know if it's continuous yet, but we have a few signs to tell if it is or not. They tell us that f is a twice differentiable function. If anything is differentiable, that is a sign that it is continuous. Twice differentiable actually means you can take the derivative and you can take the second derivative. That's what that means. The other reason that they actually tell you that is because if something is differentiable, it implies that it is also continuous. So actually, this means that f is a continuous function. So differentiable just means the derivative exists. So, okay, so we have a few things right now. The first thing is we know that f is continuous because it's differentiable. Unfortunately, they aren't asking us about something regarding f, they're asking us about something regarding g. The question is written in a way to make it as hard as possible, because even if you get that f is continuous, if you just write that, you actually won't get the credit for continuity, because they're asking you about the function g. However, because we know that f is continuous, and because we know also that x squared minus x is continuous, g must also be continuous because it's a composition of two continuous functions. So be careful in this type of question. Usually it's more straightforward than this. Not always. This is an example of where it's not straightforward. So for saying it's continuous, g is continuous, you get a point. So this is the intermediate value theorem. So we've already established that the function g is continuous. The next thing that you need to do is you need to figure out your g values of the two endpoints, and those are going to be 0 and 3. So g of 0 is going to be f of 0 squared minus 0, or just f of 0. If you look back up at the table, that's going to be 4. G of 3 is f of 3 squared minus 3, or f of 6. If you look back up at the table, that's going to be 7. So that's the first thing. I'm going to actually draw you guys a little picture so you can see what's happening here. So I know that when x equals 0, my y value is 7. And I also know that when x equals 3, my y value is 4. Because the function is continuous, I know that no matter what the function looks like, even if it goes like up and down crazily, or more realistically, if it just kind of goes like that, no matter what the function looks like, at some point, it's going to hit 5. So at some point it will hit 5. That's what the intermediate value theorem is saying. Now, I think I wrote this in my last FRQ scoring guidelines. If you draw a picture like this is a sketch. I don't actually know what G looks like. The College Board is completely within their rights to take off points for that, so cross it out. Anything that you cross out, they will not score. So I'm actually going to write my explanation based on the intermediate value theorem that I have right next to me. So I've already established that it's continuous, so I don't need to worry about that. I'm just going to kind of copy almost this exact thing right here. You can almost recopy it word for word. So you're completely allowed to do that because it's a theorem, it's not plagiarism. If you want, you can go back through the intermediate value theorem and replace things. We know that instead of the function f, we're actually talking about g. So my a and b values are 0 and 3. The k value in this case is 5. Anywhere that I see f, I know we're actually using g as the function. So I don't know what c is, and there's actually no way to figure out what c is. I think sometimes people try to actually solve for c, and that's where they get in trouble. So I'm just going to rewrite, this is 3 by the way. I'm just going to rewrite the entire thing in almost the same language that I have in the theorem. So you can see I just rewrote the theorem. Since g is continuous on 0, 3, and 5 is between g of 0 and g of 3, then there's at least one c in the interval 0, 3 such that f of c equals 5. So if you get these types of problems are actually pretty weird. You get a full point just for checking continuity. This part right here is actually only worth 1 point. So even if you really have no idea how to use either the mean value theorem or the intermediate value theorem, if you're able to show that the function is continuous, then you probably will at least get one of those points for the problem. So here's another interesting problem. They give us the function h. They actually don't give us h. They give us the derivative of h. They want to know at what value does the instantaneous rate of change of h equal the average rate of change of f over the interval -3 is less than or equal to x is less than or equal to 0. So the instantaneous rate of change of h, that's going to be found by evaluating h prime at a certain value. The average rate of change actually is different. So there's a formula for that. And the formula here is going to be f of 0 is minus f of -3 over 0 minus -3. And I just realized I forgot to paste in that table. But if you look back at the table, you'll see that f of 0 is 4 and f of -3 is -5. So your answer is going to be 9 over 3, which gives you 3. So actually, if you get that far, which this part isn't that hard as long as you know the formula, you get a point for doing that. Harder part of this problem is trying to figure out the x value where the instantaneous rate of change of h is equal to that. So you need to recognize that that's going to be h prime, which we know is 4e to the cosine of x. We want to figure out where that is equal to 3. So this type of problem is really, really hard to do by hand. Luckily, you will have a graphing calculator available to you. So you are going to just solve this on the graphing calculator. I'm going to show you how I recommend that you solve it. And actually, anytime you have an equation to solve, you can use this strategy. So my recommendation is going to be to graph each of the two sides of the equation. So in y1, you're going to want to put 4e to the cosine x. In y2, you're going to want to put 3, which is just going to be a straight horizontal line. The next thing I want you to do is you need to find the intersection point. And actually, you're finding the intersection point between those two x values. So please actually try this problem on your own. Make sure that you can do this. It's really important that you're able to solve an equation this way. I can almost guarantee you'll have to do this at some point on the AP test. If you are not sure what to do, I recommend maybe looking up a video for your specific calculator that shows you exactly how you do it. If you still are really having trouble, send me an email. I will tell you that the graph of these two functions, you're going to get something that looks kind of like this. So, and then if you draw everything right, you're going to want to be finding this intersection point right here. And for that, you need to find your x value. The y value should be 3 because that line is 3. So the x value that you should get for this is -1.863. So if you get that, you get the answer. So again, please try that calculator stuff on your own. Make sure that you can do that. Let me know if you really can't figure it out.